All right. Hello, everybody. I hope you guys are all doing well. I apologize for the delay in getting this homework review out to you. I am still having issues with getting my iPad to connect to my laptop. So I spent about an hour and a half on the phone with a company that runs my Wi-Fi. That they couldn't get anything squared away. I had a help desk ticket into the program I was using that wasn't connecting. I've emailed two of the different tech people at our school, and no one seems to know what the heck is going on with my computer and my iPad and why they won't connect. So I've had to switch it up here a little bit. I'm actually using the screen recording feature on my iPad now and Notability to try to go over this homework. So we can still continue to give you these videos because I think they're beneficial for you to see me solve these homework problems and hopefully help offer some clarification if you're having any trouble completing the problems. So let's get started. Today I am going to go over the Chapter 8, Section 1, Skills Practice, Worksheet 1 through 14. And so these questions wanted you to determine whether each expression is a polynomial. If it is a polynomial, find the degree and then determine whether it is a monomial, binomial, trinomial. So there's quite a bit going on there. So basically, you need to classify these with two names. You need to say whether it's a polynomial, and then you need to, I'm also going to include what type of polynomial it is. And then we need to say how many terms it has, and that's where the monomial, binomial, trinomial comes in. Now, I did receive a question or two for some people that were maybe a little bit confused as to what a polynomial was. Actually, if you look at 1 through 6, every single one of those is a polynomial. So those are all examples of what a polynomial would look like. Here's a couple of examples before I complete this homework of what a polynomial is not. If you had y to the negative 4 power, okay, right here, this power being a negative would make this not a polynomial. Another thing that would exclude something from being a polynomial is if you have any square roots. Any square roots, any negative powers, anytime you have a variable down on the bottom, which hopefully you guys recognize that this is the same as this. All of these things that you see across here make these not be a polynomial. So what you're looking for is you're looking for all positive powers. You don't want any fractional powers, and you don't want any variables on the bottom of a fraction. You don't want any variables dividing any variables or even dividing any numbers. So hopefully that offered some clarification as to what we're talking about here. So let me get this, see if I can work on this eraser. All right. So let's look at number 1. I think you just heard me say, guys, 1, 2, 3, 4, 5, 6. Those are actually all polynomials. So what I want to do is I want to classify these and by their degree, and then we need to determine whether it's a monomial, binomial, or trinomial. Now, the way you classify a polynomial by its degree is you take the highest degree of the individual terms. So this term right here, this 5mt, this is m to the first, t to the first. There are 2 first powers there. Those 2 would add up to a 2. So this first term that's underlined, its degree would be 2. Well, this t squared right there also has a power of 2, and that's the only power. So both terms individually have a degree of 2, and so you always take the highest degree of the individual terms, and that's how you classify the polynomial itself. So what that means is this term is, its degree is 2, and this would be called a binomial because there are 2 individual terms. So this, again, degree is 2, and it's a binomial. Number 2, if you look at the first, there's a term here and there's a term here. So once again, there are 2 terms. Each of those variables has a power of 1. So 1 plus 1 is 2. So the degree of the first term is 2. the degree of the second term is just 1. So therefore, the overall degree of the polynomial is the highest degree of the individual terms. So the degree in this would be 2, and there are 2 terms, so it is called a binomial. Now, number 3 is just an individual number, 32. That's a constant. That is any constant has a power of 0, therefore the degree of this would be 0. So no matter what number there, if there's just a number with no variable, the degree is going to be 0. And since there's only one term, this is a monomial. Whoops, sorry. Number 4 is 3/7 x. Now, it is okay to have that 7 on the bottom right there because it's not a variable. If there was a variable on the bottom, this would not be a polynomial, but because it's just a number, we're good. The power on x is to the first power. Therefore, this is a first degree, and there is only one term. So again, it's a monomial. Number 5 has 2 terms. There's a term there and a term there. And looks like I was wrong because I did not see that power right there is actually -4. And at the beginning of the video, I said, if you have any negative powers, then that means it is not a polynomial. So I did not see that negative right there. So number 5 is not a polynomial. That is not a polynomial. I'm going to write NP for not polynomial. Number 6, we have 2c squared plus 8c plus 9 minus 3. Now, of course, the plus 9 minus 3 can be combined and turned into a 6. But what I want you to key in on, and the reason why they did that is they tried to trick you to think that it had 4 terms, when in actuality, this should be 2c squared plus 8c plus 6. And so what we see is there's 1, 2, 3 terms. So that is called, when you have 3 terms, that's called a trinomial. And the highest power, this c is c to the second, this c is c to the first, and there's no c over there. The highest power in between the terms is 2. So this degree of the entire polynomial is 2. And because it has 3 individual terms, we call this a trinomial. And I apologize for the lousy writing, but I was running out of space. Okay, so moving on. That was 1 through 6. Now I would ask you to find each sum or difference. And to find each sum or difference, you are simply going to add up the like terms. Now, before I add the like terms, I like to highlight the individual terms so they're the same. So you can see there's a 2x right here and there's a 4x right there. And then changing to an orange highlighter, there's a 3y and a 9y. So as you can see, by highlighting those terms, those are like terms. So the like terms are going to be added together. So looking at the yellow terms, we have 2x and 4x, which is 6x. And then looking at the orange terms, we have 3y plus 9y, which is going to be 12y. And I just realized that is number 15, which we don't want to do. So I have to try to figure out how to scroll. I apologize. There we go. I skipped to 15. Sorry about that, guys. That's a little ahead of the game there. Looking at number 7, it says write each polynomial in standard form. Identify the leading coefficient. So standard form is when you list it by the highest power to the lowest. So by ordering this, you can see that right there is the highest power. So it's 2x to the second, followed by 3x, and then your plus 1. So it says write each polynomial in standard form and then identify the leading coefficient. The leading coefficient is always going to be the number that is in front of the first term. So in our case, it's 2. The next one, excuse me, is 3x squared. So that's the highest power, plus 5x minus 6. So you can see we started with an x squared, then we have x to the first, and then we have 6. And the leading coefficient is going to be the number that is in front of the highest powered term. So it's a 3. Next one, we have an x to the third, which is going to be first, plus 9x squared. And then plus x to the first. You don't have to put the 1. It's not there, but it is there. And then plus 2. The constants, the numbers that are by themselves with no variables, always go last. So you can see we have the powers ordered from 3, and then 2, then 1, and then there is no power. So looking in front of this variable, we say, well, there's no number, so it's 0. But if it were 0, 0 times x cubed would actually cancel the x cubed. So it's not 0. There is indeed a 1 right there. So the lead coefficient is 1. Moving on to the next one, we have we don't have negative. We have 3x to the third first. Then we have minus x squared plus 4x, then minus 3. So you can see the powers on the x go 3, 2, 1, and then there is no power, and the lead coefficient is 3. Number 11, 3x to the third plus x squared. Oops, not plus. That should be a minus x, and then plus 27. Looking at the lead coefficient, it is 3. Negative x to the third. Now, if you notice, it jumps from x to the third directly to x to the first. There is no x squared, and that's okay. Now, some people might write minus 25. Remember, the minus belongs to the x cubed. The 25 is actually a positive 25. And so looking at the lead coefficient, this number right there, that is going to be negative 1. So our lead coefficient is negative 1. 2 more. 5x to the third minus 3x squared, then plus x, then plus 4. Lead coefficient is 5. Last one, 7x to the third plus x squared minus x plus 64. And your lead coefficient is going to be number 7. Okay, guys, that's it. We got through 1 through 14. I even did number 15 for you, or at least started doing it for you. That's going to be part of your next homework set tomorrow. Hope you're all doing well. Take care. Talk to you soon.